I recently upgraded from the Precision Matthews PM25 mill to this PM728 for a number of reasons. And I've done some modifications which I'm going to explain in this short video. This is my new PM728 mill that I'm starting to do some modifications to. I have put on the DRO and the X scale and the Y scale there. And I'm not going to put a Z scale on it because this LCD quill scale has some issues. It has a timeout, so if you're doing a long operation, it suddenly turns off right when you need it. So it's annoying. It's also very hard to see, even when it's working properly. And it's battery operated, which is kind of just goofy. So I'm going to mount a 4-inch scale, replacing that one on the quill. And then that will be my Z-axis on the DRO. I have never used the DRO in the Z to set a height. I always just set the height by eyeball down close to the work and then use this little LCD screen for the actual quill movement. This will be the replacement front plate. Working on that. I'm gonna go right there. So that's the plate. This is the plate. Go there. And the last piece is this bar that the scale head mounts to. I'll go right up here. Somewhere like that. There's a couple extra holes there because this is a scrap piece that I found. But that'll work just fine. I believe I have all the parts made now, so I'm going to remove the existing scale. That was pretty easy. I got to figure out where I'm going to route my wire. I'm just test fitting this. For the dust guard for the quill scale, I modeled it flat in SolidWorks, printed it out 1:1, and then I spray adhesived it to a piece of construction board, railroad board. Now I'll cut it out, fold it, make sure it fits, and then cut the metal. So I've scored and folded the puppet, as they call it, so I can test the fit on it. And that looks like it's going to fit perfectly. I'm just going to turn it into metal. And here's the final quill scale with its dust cover. And over here I'm going to be mounting an AC servo motor for rapid movement of the X direction. It's an AC servo motor because that way I can still manually turn this. If I use a stepper motor, it has the cogging effect, which makes it really hard to move manually. And I will be mounting a stepper motor up on the Z, on the column, for rapid movement of the Z. This is the stepper motor that I'll be using on the column for rapid Z movement. That's the power supply for it. This is the AC, or actually this is the stepper motor driver. And I'm working out the drive frequency with a little oscillator that will control the speed. Okay, I've got my motor test set up. That's the Z motor that's going to go on the column of the milling machine. And I just have a little 555 oscillator and a buffer running at about 1 kilohertz. And so if I connect the oscillator to the driver. My motor turns. And to reverse it, all I need to do is pull the direction signal high. I got an off-the-shelf coupling for the Z motor, but it's too large a diameter to clear the bevel gear, so I made a new half of the coupler. The set screw down below lines up with a little slot on the lead screw. So for the Z motor mount, I decided to go with simple spacers and a thinner plate on top instead of having a big solid block of aluminum. So these guys have these little covers that cover the sides to keep debris out. Goes like that, goes like that. Like that. And the top plate goes on. The motor will go on top of that. And the little side guards are just Delrin, 1/4-inch Delrin. Working on the X motor adapter. So far I have the bore cut. I'm checking to see if that fits. Oh, that's nice. Great. Okay, I've finished the adapter for the X motor. Just go here. This will go here, like this. And there'll be spacers connecting to the motor. So now I'm going to make the spacers. Working on the control box for the X and Z motors. Conventional electrical box that I'm putting it in. This is the front panel. The up, down, and left, right switches. And I'm gluing in some LEDs there. This is the circuit board with the two oscillators, the two driver signals. Potentiometers. Potentiometers go on the side here. Coming along nicely. Here's the control box with the wiring done. I still have to determine the sense forward and reverse and up and down on the switches, which I'll do once I have it installed on the machine. I've tested the circuit board and the oscillators work now, so it all looks like it's in good shape. I just have to get the sense correct on the left and right and up and down travel, then I can close this up. I finally have my X and Z motors installed on my PM728. There's the AC servo motor for the X drive, and then a conventional stepper motor for the Z drive. There's the 48 volt power supply here, 12 and 5 volt supply here. Got a relay for the 220 volt line coming in. And that's the stepper driver. That's the AC servo driver. And still gonna clean up some wiring and add some more ties. And I'm going to put a dust cover on this eventually. So that's the control box now. This is the enable switch for the servo, so that when you're not driving it, you can turn the hand wheel by hand. Otherwise, if it's in servo mode, it won't let you turn it. Very quiet. And the speed's adjustable, though I'm normally going to have it probably on full speed. Just leave those fully up. So all in all, pretty cool. Oh, and the reason that the DRO doesn't respond here is because I've got that attached to the quill now, which makes a lot more sense for how it's being used. So it only operates with the quill now. This is with the cover back on, just a screen mesh to keep out large particles of metal, but allow free airflow for cooling. All right, I think it's done. One of the last things I did was make the little dust cover for the X motor coupling. And then I also shortened the scale cables because they, as provided, they're very long and you have to kind of loop them around. So I just shortened those to fit. Hope I don't regret that in the future. All in all, it was a really fun project and I'm looking forward to making a lot of parts.